Good evening, everyone, and thanks for making out on this rainy evening, and thanks to everyone online for joining us as well. Just note that the fire exit's on the door. You just came in, and you might just put your mobiles to silent if you haven't already. Our lecture this evening is on principles of passive safety and the changes to EN 12767, and we're delighted to welcome Ian MacDonald from Norsk Hydro, who's worked in the highways industry since 2008, working in the ITS sector, and currently heading up the UK and Ireland operations for Pole Products, a division of Norsk Hydro. So Ian's going to talk to us about passive safety and their products there tonight. So I'd just like to give you the podium and we'll get going.
Okay. Thank you. Thank you very much. Yeah, thank you to everybody for taking the time to come out this evening. And again, for those people online, thank you also. I'm going to go through the passive safety with you. Don't make any apologies for going back to basics when I do this presentation, because passive safety has been around for quite a while. But it's always good to have a bit of a refresher on where we are now, and then we'll have a look at the new standard and the changes within it. So very quick history on passive safety for you. We'll go through the different classes, we'll talk about the testing methodology, and then we'll have a look at the new classifications and how the norm is changing. There's also some guidance documents that I'm going to talk through with you. And an important consideration when we're talking about passive safety is also electrical disconnection. So we'll have a look at that while we're here as well. So a brief history of passive safety. Passive safety has actually been around for a long, long time. It was originally an idea developed in Scandinavia. The first European standard was published in 2000. And the first installation in the UK was back in 2002, and around that same kind of time was the first installation over here in Ireland also. The passive safe norm didn't become a mandatory document until 2008, and we were well overdue a revision of that norm, which is now arrived. So why do we need passive safety? Well, unfortunately, happened 40, 50 years ago is still very, very true these days. And I think it's actually getting worse. The volume of traffic on the road network is only increasing, and particularly for young drivers having such accessibility to new vehicles now with low finance schemes and free insurance for first-time drivers and things like that, you've got a lot of inexperienced young people out there on the road as well. So rather than the situation getting better, I believe the situation on the road is actually potentially getting worse. So it is something that we do need to consider. Right. So when we're talking about passive safety, I think it's also good to have a look at what happens with a non-passive product as well. So I'm going to show you a video of what potentially happens when you impact a non-passive safe lighting column. So this was done at 70 miles an hour, so 100 kph, into a 10-meter traditional steel lighting column. It was at an event which we arranged a couple of years ago back in the UK. And it was to show people the differences between passive safe objects and non-passive safe structures. So I'll just let this play through. Now, I'm not saying that this is what happens every time a car leaves the road and hits a steel lighting column, but this is potentially what can happen. The actual damage to the car itself, upon impact, it rolled the car 3 times, and it made a bit of a mess of it. So that was the aftermath of the crash itself. If you're a passenger in that car, you'd have been in serious trouble. The driver might have got away with that one, but the passenger certainly wouldn't have done. And that was the front of the vehicle after the impact. And we did purposely choose a big heavy car as well. I could have chosen a small family hatchback to do this, and it would have completely obliterated the car. But I wanted to show purposely what can happen if you've got a big heavy car hitting a non-passive object as well. And we did it right. We did it with a Jaguar V8, so it was a fitting end to a very old car. It was a good day. If you ever get the opportunity to attend these crash demonstration events, then please do take that opportunity, because until you're actually there and physically see it and hear it, and the noise that it creates and the violence involved in one of these impacts, it really does bring it home to you. So let's start looking at the passive safety side of things. So there's 3 different energy absorption classes. We'll start with non-energy absorbing structures, Now, these are designed not to slow the vehicle down upon impact. It's designed to allow the driver to regain control of his vehicle after the impact and bring it to a safe stop. So you generally find these big poles, like 15-metre lighting columns like these, at the sides of motorways and where you've got decent runoff area. This video I'm going to show you now is a 100 kilometres an hour, obviously slowed down, into a 15-metre non-energy absorbing lighting column. And what you'll see is no discernible reduction in speed of the vehicle at all. And the lighting column actually goes up and over the car, allowing the driver to regain control of the car. And the column itself comes back down exactly where it's planted. So nothing is taken back into the carriageway, going left or right, presenting a greater risk to anybody else in that environment. And that's an NE3 lighting column. That's kind of the Rolls Royce of passive safety, if you like. The kind of middle classification is a low energy absorbing structure. These are designed to slow the car down, but not stop it. So again, allowing the driver to regain control of his vehicle upon impact. There will be a slight discernible reduction in speed upon the impact, but it's not going to stop the car. Again, the car carries on in the direction of travel. It's taken the lighting column with it, in this instance, taking it away from the point of impact in the carriageway. And what you will see on this video is that the lantern has become detached from the top of the column. But again, that's coming down where the column was planted, and it's not presenting, any additional risk to anybody in the area. It's not flying off down the road like a missile and taking little Johnny's head off as he's coming out of school or anything like that. So it's all contained within the point of impact. And the other end of the spectrum from no energy is high energy absorbing columns. Now, these are designed to stop the car in a controllable manner, take control away from the driver, and it's the product itself which will bring the car to a stop. Now, I'm going to play this one at full speed, at real time. You'll have to bear with it for a moment, but it'll come in. And I'm going to dwell a little bit on high energy absorbing structures before we move on. Again, it's 100 kilometres an hour. Wait for it. So that's 100 kilometres an hour to 0 kilometres an hour in 8 metres, but in a controlled fashion. Now, you're not going to put high energy absorbing lighting columns in everywhere. You're going to put high energy columns in for a very specific reason. There's something behind that lighting column that you don't want the vehicle to interact with if it leaves the road. So there may be a footpath behind there, there may be something else behind there. You want to stop the car. If it hits the column, you want to stop it. Now, high energy absorbing structures are generally engineered solutions. What we're talking about here is poles, basically, cylindrical tubes. And to be able to get a car to stop that quickly and that controllably in the event of an impact, you have to do something with it. So there's different types of high energy absorbing structures on the network. They're all classified as high energy absorbing, but they do it in very, very different ways. So when you're doing your specifications and doing your designs, what I would always advise you to do is ask the manufacturers the manufacturer of the product you're thinking of using for the videos, like you've just seen now, so you can judge for yourself if what you're intending to specify will actually do what it says on the tin and stop it before this secondary impact can actually occur. Yeah, it's not so. Don't really need to do that so much with non-energy absorbing structures or low energy, because they're very predictable in the way they perform. You've seen that on the video. So they're very predictable in how they're going to perform, but high energy structures are not. They do it very, very different ways. So the testing methodology itself. First thing is the validation of the test vehicle. It can be no more than 900 kilograms in weight. So it's a very small family hatchback like a Ford Fiesta or something like that. The videos you've just seen are all Suzuki Swifts. They must have a surplus of Suzuki Swifts over in mainland Europe, and they're just trying to get rid of them 10 a penny or something like that. So small family hatchback, 900 kilos, and it must be roadworthy. So the brakes have got to work, the steering's got to work. It's got to be able to drive on the road if you like. So for every certification that you're looking for from a manufacturer, you have to do 2 tests. The first test is a slow speed test, which is mandatory. You have to do that one at 35 kilometers an hour. It's the most onerous to pass, so you'll do that one first. And if your product doesn't pass the 35 kph test, there's no point going and doing the high-speed test. So when you've done the slow-speed one, you will then choose as a manufacturer whether you want to do the second test at 50, 70 or 100 kilometers an hour. Now, most manufacturers will opt to do a test at 100 kilometers an hour. So you've done the slow-speed test, you've done the high-speed test, so you're encapsulating everything in between, basically. Tests themselves have to be done at an accredited test house, and they have to be supervised by a notified body for you to get your certification. So the first video I showed you of the car hitting the steel lighting column, that was what we call a demonstration. So there's no telemetry in the car or anything like that. So those kind of demonstrations, they can't be classed for certification. They have to be done at an accredited test house and supervised by a notified body to get the certificate at the end of it. Now, we've seen the energy absorption classes, high energy, low energy and no energy. They're determined by the exit speed at a point 11 meters after the impact. So for a high energy absorbing column, if your impact speed is 100 kilometers an hour, it needs to be 50% or less exit speed at a point 11 meters away from the initial impact. The video you saw of our product earlier had an exit speed of 0 because it didn't actually get to the measuring point. So that's what the energy absorption classes are determined by. On the other side of that, on the right hand side, is all to do with the safety of the occupants. There's always telemetry in the vehicles. They always have a crash test dummy in there, and there's two critical measurements that are taken. The first one is the theoretical head impact velocity, and that's basically a measurement of how hard your head's going to hit the dashboard in the event of an impact. And the second one is the acceleration severity index, which is a measure of g-forces over a short distance, 30 centimetres, and the g-forces that's involved. These are really, really important measurements. What people don't realise is it's not generally intrusion into the vehicle that kills people when you hit something. It's the internal injuries that kill people. If you imagine you're driving down the road and you come off the road in your car and you hit an old oak tree at the side of the road. So you're doing 100 kilometers an hour, you come off the road, hit an oak tree, you're going to stop dead. But all your internal organs are not, and your brain's not. They're still traveling forward at 100 kilometers an hour. Yeah, so your brain's going to hit the inside of your skull, and all your internal organs are going to go into your rib cage. Your ribs are probably broken, so it's going to puncture your internal organs, and that's where most fatalities occur. Yeah, I know that intrusion into the vehicle can cause horrible life-changing injuries, but it's not the main reason for fatalities. It's the instant stop that kills people generally. So out of these two measurements, the old norm gives you 4 occupancy safety classes, from 1 being the lowest up to 4 being the highest. Now, class 4 is only achievable for non-harmful structures such as keep left arrows and deformable bollards that you go over your car and they spring back again. For a lighting column, signpost or a signal pole, the best classification you'll get will be a class 3. Yeah, so that's the safest one for the occupants of the vehicle. When we're talking about passive safety, there's always been this perception of risk that if I put a passive safe pole in an urban environment, that it's going to wipe out somebody behind, and there's this risk of secondary accidents. And that is contained and it is addressed within the actual testing norm itself. As a manufacturer, you have to predict to your the test house and to the notified body how your product is going to perform before you actually do the test. If it doesn't perform as prescribed in that report, when you do the test, you don't get your certification. So there can be no unknowns there, if you like. The second part is that, as you've seen on the videos already, anything that's attached to that pole, whether it be a signal head, a sign plate, or a street light, or a lantern, has to stay contained within the impact area. It can't go flying off down the road and present a secondary hazard to anybody else in the environment. And the last bit is to do with the vehicle. Not on high energy absorbing columns, because that's taken out of control of the driver, if you like, and has stopped very quickly. But for no energy and low energy absorbing structures, the car's not allowed to pitch and roll more than 45 degrees. And the reason for that is so the driver can regain control of the vehicle and bring it to a safe stop. And we're seeing now more and more local authorities using aluminium structures, which are inherently passive safe, as their standard product, whether it's a street light or a traffic signal pole or a signpost. Not because it's passive safe, but because they get an extra longevity out of the product, because they get 50 years out of it. But if they thought there was any additional risk by putting an aluminium passive safe pole on their network in a slow speed urban environment, they wouldn't do it. And I've been doing this now for over a decade, and I'm yet to come across any recorded incidents of a secondary accident to anybody after an initial impact with a passive safe object. It just doesn't happen. They're a much, much safer option. So that's what a current passive safe classification looks like. That's what we should have become accustomed to over the past 10 years if you've been working with passive safety. So the first part is the impact speed in kilometres an hour. The middle bit is the performance level, the energy absorption level, and the last bit is the occupant safety. So nice and straightforward, simple to understand. The new standard is now actually in force. The document itself was published in the summer of last year, and it became a working document this month. So any new designs that you're doing for passive safe products will now need to be in line with the new standard. And your new classifications are going to look like what it says at the top. So it's a little bit more complicated. I'll work you through it. So the first bit stays the same. It's your speed and your energy absorption class, NE, LE or HE, that stays the same. The next bit is the occupancy safety level. So it's gone from numbers and 1 to 4 to letters from A to E. They've introduced another class in there. And what they've done is tightened up on the measurements for the theoretical head impact velocity and the acceleration severity index and made it tighter. So they've introduced an extra classification in there. The next part is the backfill type. It'll be S for soil, R for rigid, or X for something else. And that's the backfill type you've used when you've tested the product at the test house. The following bit is the collapse mode. It's either going to be NS for no separation or SE for separation. So for a high energy absorbing lighting column, it will generally be an NS, but no separation because it stays intact and encapsulates the car upon impact. Low energy and no energy absorbing structures will always be SE by their nature because they don't want to slow the vehicle down. The next two parts are the main changes, which are really important. I'll go through them now briefly, but I'm going to dwell on them a little bit more in the coming slides. The next bit is the directional sensitivity of the pole. There are some poles on the market which are only certified to work in one direction of impact. So you've got single directional poles, bi-directional poles, or you've got multi-directional MD directional poles. So you've got different types of poles, classifications there. And the last bit relates to the roof indentation. So how much the roof deforms when the pole comes back down on top of it, particularly pertinent for high energy absorbing structures as they wrap around the car and stop the car. You've got two classes now. You've got class 0 and class 1. Class 0 is less than 102 millimeters of roof deformation. Class 1 is 102 millimeters or more. Now I know 102 millimeters sounds like a really funny figure, but for those of us in the room of a certain age, we'll know that 102 millimeters is 4 inches. Yes, you knew that in the front row there, didn't you? I saw that, yes. So that mirrors the American standard. In America, they say they've gone one stage further than us. So they say if it's 102 millimeters or more, it's not passive safe at all, and it's not going to get its certificate. We don't do that. We give you two options. So less than 102 millimeters is class 0, more than 102 is class 1. I do think in the next revision, probably in about 5 years' time, that we might go one stage further and adopt that American methodology. But that's not here yet, and I'm only guessing, but it seems sensible to me. If we've adopted it now, that the next stage would be to go that one stage further. So directional sensitivity. When you're doing your actual crash test, you do it off-center, so you try and replicate the car leaving the road, so you'll do it at an angle of 20 degrees. So there are some products out there that have got engineered solutions within them that will only work if the car leaves the road and hits it at 20 degrees center. Not great. There are other poles out there that are bi-directional, so they'll work at 20 degrees in one direction and 160 in another. Obviously, the best case scenario is a multi-directional pole. Doesn't matter which direction it's hit, the pole's still going to perform. And the norm guides you towards always starting when you're doing specifications and your designs to start with a multi-directional pole. So you start with the best possible solution. If for any reason you're looking at a particular product and you need it to hold a particular lantern or sign or something like that, and you can't find a multi-directional product out there to do it, then it advises you to look at a bi-directional product. Failing that, last resort is to then adopt a single directional product. But I think it would be very rare for you, to be honest, not to be able to source a multi-directional product for any of your installations. Roof deformation. There's another extract from the norm there. It again tells you that when you're starting your design, always start with a class 0 for roof deformation. And then if there's a product out there that you need to use and it's a class 1, use it, but always try and look for a class 0 first of all, because it's the safest solution. It makes common sense, but historically they've only put it in there as guidance, but they've actually now made it a part of the norm. Within the norm itself, there are performance class recommendations. You probably can't see that very well. It does say miles per hour on there rather than kilometres an hour. I do apologise, it's an extract from the UK norms, sorry for that. So, but in your version, the Irish version, it will say kilometres an hour on there. And it advises you what kind of passive safe products you should be considering for lighting columns, signs or signal supports, and then non-harmful structures as well. The top section is for high-speed roads, the bottom section is for more urban roads. Realistically now, the norm and the guidance from TII says that you should be considering passive safety for everything, irrespective of the speed of the road. So if you've not got a copy of the new norm yet, I suggest you might need to get your hands on one. There is a bit of an opt-out on the new norm, so it does look quite long-winded. There's a lot of things there to consider, but you can opt out of certain areas when you're doing your designs and your specifications. First 2 bits, the impact speed and the energy absorption, you can't. They've got to stay the same. And you can't opt out of the last 2 bits, the directional sensitivity or the roof deformation either, really. So the 2 kind of bookends of the new standards have to stay in there. But you can, if you're not bothered about occupancy safety level, what backfill type or what the collapse mode is, you can get rid of those 3 bits, the C, the S and the NS, and just put NR in there. So it shortens it and makes it, a little bit easier to understand, if you like. I personally don't know why you would discount the occupancy safety level, because that's what passive safety is all about, isn't it? Looking after the people in the vehicle and making sure they're going to walk away from it. But yeah, if you want to shorten it, make life a little bit simpler for yourself, you can do. The backfill type is actually quite important, and we'll go on to the kind of installation of these poles in a bit, and we'll talk about that in a little bit more detail. But there are some documents out there which hopefully some of you will be quite familiar with. This particular document's been around for a number of years now, and it's moving towards a safe systems approach to road safety. So it's mitigating the behaviour of the driver, and telling people you should start considering forgiving systems, VRS restraints, and passive safe poles. It's guiding you down that route. It's currently being rewritten at the moment because it's a little bit outdated now. So that's currently being rewritten. Another document that you should be familiar with is a TII document, Design of Road Lighting. This is quite a new document published in August 2018. TII are currently working with Arabs to update all their information, get it in line with the new standard itself. But contained within that document, it makes reference to the previous one. So section 2.2 points you in the direction of the forgiving roadside document. And basically what it's saying in there is if you can't get your lighting column out of the clear zone on the side of the road, and you can't put a VRS system in there, then rather than it being a recommendation before to use passive safe poles, it now says in there quite clear that passive safe columns shall be provided. So it's not optional anymore. You shall provide passive safe columns if you can't get them out of the clear zone. Another section within that TII document, section 3.8, talks about electrical disconnection. It's very important that you do consider electrical disconnection with passive safety as well. So in the event of an impact, you've not got any live poles lying on the ground and presenting a risk to the emergency services when they're coming to help people out. Standard says that it needs to disconnect within 0.4 seconds upon impact, and I'm going to talk a little bit more about the disconnection systems in a second. But also in 3.8, it guides you to another document called TR30, which is published by the Institute of Lighting Professionals, or the ILP. And that document is a really good document, and it kind of holds your hand through the process of specifying and choosing which passive safe product you want to use. So I know you can't read it on there, but it's a little flow chart with yes and no answers. If your answer's yes, and you go one direction. If it's no, you take another direction. So it's really simple. Hold your hand through the process and the design process. Also in that document, which I think is vitally important, is a blank risk assessment form. So a very, very simple risk assessment form that you can use and you can adopt and take it with you, so that you're filling it in as you go in. So you're making sure you're ticking all the boxes when you're considering it. That's available for anybody that's a member of the Institute of Lighting Professionals as a free download off their website. So if you've got anybody in your offices who's a member of the Institute of Lighting Professionals, I would certainly recommend that you download that and have a look at it. Really, really good document. It's being rewritten at the moment. So I say download it. Is it still available as a download now, even though it's been rewritten? So you can still get it now. It won't be fully in line with the new standard, but it will still hold your hand through the process. The process is still the same, what you need to consider and what you don't need to consider when you're thinking about passive safety. So yeah, a good document to look at. So disconnection systems, electrical disconnection. Plug and socket disconnection systems have been around for a long while now. It's basically dot plug, so they just pull apart upon impact. They were what first came out when passive safety came around. They were okay at the time. There was no other solutions really available, but they are limited in the way they perform, because they're not guaranteed to perform correctly every time. It depends on how the pole's been impacted and how the pole performs upon impact for the disconnection, the breakaway plugs to actually perform. By far and away, the better disconnection system is the electrical disconnection systems. So this is done by means of an impact sensor within the column itself. And these impact sensors, you'll be able to see the little switch, the red switch in the top of the door section there. That disconnects the power in 0.2 of a second. So it's exceeding the standards in the norm. If you look at the red light on the traffic light, on the video, if it plays, that's how quickly it should go off. Yeah. Got a couple of videos for you on disconnection systems. Again, just to demonstrate to you, you've got different types. You've got above ground systems and you've got below ground systems. But they all work very, very effectively upon impact. So what you need to look for is the control panel on the left there. Look how quickly the switch comes down upon impact. So that was an impact at 100 kph into one of our 15-metre lighting columns with the disconnection system provided by our friends at IPL. This is the underground system. Again, look at the switch. It turns it straight away. There we go. And then the last video is another view of the first one you saw into the traffic signal pole. Traffic signal pole installations now, I think it's fair to say, most new installations go in with ELV, extra low voltage cables. So the thinking is now, do we need a disconnection system with new traffic signal installations? Some people do it, some people don't. But certainly on lighting columns, I know you don't illuminate your signage over here like we do in the UK, but for your lighting columns, you certainly have to consider some form of disconnecting that power upon impact. Another product which goes hand in hand with passive safety are retention socket foundations. I'm sure you're all aware of retention sockets, and I'm not going to stand here in front of you today and say every passive safe lighting column you put in must be in a retention socket, because you're just adding cost onto cost onto cost all the time. But what I would say is, if you've got a particular site which is regularly getting hit, over in the UK we have a 3-strike rule. So if a local authority's got a traditional steel pole on a bend, it gets knocked, it gets hit, they'll put another steel pole in, and they'll think, like, lightning never strikes twice. If it gets hit again, oh, okay, I'll put another steel pole in. If it gets hit a third time, that's when they start thinking, well, I've got a bit of a problem here, we need to do something about this, and they'll put a passive pole in there. But because it's got a history of being hit repeatedly, and they're having to do all the civils work and everything else that's associated with it, 99% of them will go in a retention socket then. Because the removal of the stump of the pole and replacement of the pole can be done in minutes. I'm going to show you a video on how that works now. And I will point out, this is not a passive safe pole that you're going to see now. This is, again, it's a traditional steel pole, but the principle is exactly the same. What I would point out on this one as well is if you have issues with planting depths, you can get away with a very, very short root system on a retention socket as well. That root section was 380 millimetres, I think. So that was an impact into a non-passive safe pole. See the airbag and everything going off in the car. But what we're interested in here is not how the pole performs, it's how the socket performs. There you go. And that's your socket, and that's your pole out of your socket. Straight away. Put the pedestrian cap in just to make it safe until you get the new pole. But then all your cables are still in there. So you just tuck your cables down into the socket. When you get your new lighting column, feed the cables back up, drop your lighting column into the socket, away you go. Makes life a lot simpler for you out in the field. Things to consider then when we start talking about passive safe poles. First thing you need to think about is, because it's a passive safe pole, it still needs to comply with the regulations and norms relating to the strength of the pole and the design of the pole itself. So an aluminium lighting column needs to conform to EN40 straight away, EN40-6 for aluminium, or if it's a signpost or signal pole, first thing it needs to do is conform with EN12899. After that, things that you need to be looking for when you're doing your designs and you're talking to the manufacturers of the product you want to use is ask them for a copy of the certificate, of the test certificate themselves, ask them for a copy of the test reports, and also ask them for a copy of the videos, particularly again when you're talking about high energy absorbing structures, so you know how it's going to perform in the field. Make sure that you also get the information for the mandatory 35 kilometres an hour test, because that is the most onerous one to pass. So make sure you get all that. There should be no problem getting it. Everybody's reputable manufacturer in this day and age. So, but for your own benefit and traceability, you need to have this information in your project folder, if you like. So these are just examples of the kind of certificates that you should be looking for. The things to point out is the notified body stamp on there to say that it's fully certified by a European notified body. That's a lighting column one. That's one for traffic signal poles and signposts. What you also need to consider now as well, and what the norm takes into account, is the actual installation of the poles in the ground. We've seen on the new standard there is a bit there for the installation, the backfill material, when you're doing the test, either S for soil, R for rigid, or X for something else. If the pole has been tested in a soil backfill, a granular material, that's kind of worst case scenario, because upon impact, some of the energy from that will be absorbed by that granular material. So if you've got a pole which has been certified and tested with a soil backfill, you can then in the field go and install it with a concrete surround or with a retention socket and makes it into a rigid foundation, and it's still certified to work. But you can't do it the other way around. So if a manufacturer is tested in a rigid foundation, you cannot then in the field go and install your lighting column in a pot. The ducts that we put them in, you can't go and do that. It has to be in a rigid foundation. They're not classed as rigid. A rigid foundation would be no movement, no granular material around the pole. So if you've tested in soil, you can go to rigid. If you've tested in rigid, you cannot then go to soil. So you need to make sure that when these poles are going in the ground, your contractor is following your instructions and the manufacturer's recommendations and instructions for installing them. Other things that you need to consider, there are products out there that rely on external shear-off mechanisms to work. I see a lot of bolt-down signposts on the network over here that have external shear-off mechanisms. Make sure when you're doing your annual maintenance that these are still intact and they're not corroded, or they've not been blacktopped over. Something like that, but you laugh. But believe me, over in the Netherlands, they have a lot of lighting columns over there, big 15, 18 metre steel lighting columns with shear-off solutions at the base, bolt-down ones, and they're just blacktopped over the top of them. They're never going to work. And likewise, if you have an internal shear-off mechanism, like we offer an internal shear-off mechanism on our bigger poles, that has to be situated 150 millimetres above ground, so that when the car hits it, the top of the pole slips away from the base. Make sure that it's planted correctly, because if that shear-off mechanism's a couple of 100 mil below ground, it's not going to work. If it's 200 mil too high, there's no guarantee it's going to work properly upon impact. So things like that you have to consider and really tell your contractors to make sure they're installing them correctly. And when you're doing your audit at the end of the project, your safety audit, whatever you have to do at the end of the project to sign it off, these are the things that you really need to start looking at. Oops. Right, we offer a white paper on passive safety. In North Hydro, we are very, very fortunate that our technical manager sits on the European Working Group for passive safety, so he's had a big hand in writing this new norm, which is great for us, but it also means that he's written a really comprehensive, non-commercial document which will take you through the process of passive safety. If you read it in combination with the ILP document as well, they really go hand in hand and make life a lot easier for you when you're making your considerations. That's available as a free download on our website, so please go and download that anytime you like. Failing that, you can ask Thomas at our representatives at IPL for a copy of it. Thomas will gladly send you a copy of that. And there are other documents available to you as well. So I've spoken about the ILP document, you've got the TII documents, there's our white paper. There's also a website out there that a lot of people are aware of, particularly in the UK, but it's quite easy to find. It's called Passive Safety UK. And on this particular website is a whole library of every passive safe structure that's available for everything, lighting columns, signposts, signal poles. But please bear in mind that it is a commercial website. As a manufacturer, you have to pay to go on there. So they are very reliant on the manufacturer providing them with the correct information. So if you do go on that website and you see something that you like and you may want to use, next thing you do is start talking to the manufacturer of that particular product, get all the certificates, the crash test videos and everything else that goes along with it to back up your choice. And also, as you've seen in the European norm itself, 12767, there is a table in there of recommendations on, on what you should be looking for also. So there's plenty of guidance out there. You can always ring Thomas and myself as well if you're unsure about any of this, because it is all very new and it's all a big change. Quite happily come down here again and sit and have a longer conversation with any of you on a one-to-one basis and go through your schemes and things with you. It can be a bit daunting, but when you start getting used to it and you start working with it, it does become a lot easier. The next conversation that we're having with Highways England over in the UK is what happens in that scenario. So this was an accident which occurred on the M62 just outside Manchester just before Christmas. And basically what's happened there is you've got a traditional steel lighting column within the working width of a VRS system. So the car's left the road, hit the VRS system, which is supposed to arrest the vehicle, but it hasn't worked because the VRS system's hit the lighting column, it hit an immovable object, and it's wrapped itself around that lighting column. Now, thankfully, there was no passenger in that car at the time, and the driver, got up and walked away from it. So all his Christmases came at once. But we're currently talking to Highways England now about what you should do. It's pretty evident that there should be a passive safe column in there, but it's what type of passive safe column that you need to put in there. I mean, the first thing you need to do is avoid that scenario wherever possible and don't ever put a lighting column within the working width of a barrier. It makes sense, but sometimes it's unavoidable. So you need to kind of determine what you would do in that kind of scenario. But you've also got it's not as easy as saying, I'll put a non-energy absorbing pole in there, because there's different types of VRS systems out there as well, and they all perform in different ways. So it's a conversation which we're starting to have very early stages. We're going to be doing simulations, and hopefully the outcome of these simulations will then lead on to demonstrations and testing. And maybe in 12 months' time, I can come stand back in front of you again and let you know what the outcome of these tests actually are. But that is still very, very early stages at the moment. That's the end of my presentation, really. I just want to thank you again. I want to thank IPL for inviting me down to do this, and Thomas for arranging it. I want to thank you guys for coming out on a very wet and windy evening to come and sit in front of me. Thank you for your attention. It's been really nice to meet you.
Very good. So, open for any questions people might have. There's a lot of information thrown at people there. So, if there's any questions from the floor.
Yeah. I was just wondering about the indentation.
The roof deformation. Yeah.
Is that not very subjective depending on the car? I know that there's kind of
Yeah.
100 kilograms and whatever, but it seems that it could vary widely.
It could be. It could be. There's certain parameters that everybody's got to use, and they are small cars. They're quite old cars generally that they use as well. So, but yeah, there can be differences and variations, but there has to be a line drawn somewhere. And generally, it's only generally for high energy absorbing columns, and with them being small cars as well, they do, whatever I've seen, they do generally react very, very similarly, to be honest with you. But there are some lighting columns out there that were being used in accordance with the old standard, but now can't be used. So there are some lighting columns out there that give roof deformations of over 300 millimeters. So they were okay for the previous standard, but now they're going to have to do some retesting and some re-engineering to try and develop a new product for those. Because you could use them if you want, because you could class them as a class 1. But knowing if you get a copy of the test report and it shows 330 millimeters of roof deformation in there, you're going to walk away from it, aren't you? It's not the safest product out there. So yeah, it is subjective on the type of car, but you've got the parameters that everybody's got to use them, unfortunately. And the next thing is, we've had the question today on a number of occasions, is what about electric cars and hybrid cars with batteries in them and things like that? How do they perform? And I think that will be addressed in the next norm as well. Because we're all going to be driving hybrid cars and electric vehicles before too long, aren't they? And they're developed very, very differently.
And sorry, just to follow on just what you said, I mean, and the use of perhaps doing the tests typically older cars because they're cheap. But I suppose the crumple zones on modern cars that are designed to deform, surely also has an effect on how the car reacts, before the pole reacts to the car.
Yeah, no two accidents are ever going to be the same. No, the videos you've seen there, and they're almost laboratory conditions, if you like. So, in the event of a crash, it's very, very rare that you're going to impact into the middle of the bonnet of your car. It could be you could spin around and hit it from the back, but you can't allow for that. You can't predict that. We've personally gone one stage further and we've done side impacts into passive safe things as well. But yeah, it's just these parameters that everybody uses the same thing, and it tries to level the playing field for all the manufacturers. But yeah, no two accidents are the same. You could have a flat-fronted lorry, which has got a massive impact area on the pole. That's going to perform completely differently as well. So yeah, it's just you've got these parameters. You work to these as manufacturers. You work to these parameters. And that's as best as we've got.
Any other questions? Just following up on that, is all of the certification then based on crash testing? Is there any role for design modeling?
No, there used to be a long time ago simulations which were permissible, but not anymore. You can start with a simulation if you want in your development of your pole, but to actually get the certification itself, you have to test.
And do you find the simulations reflect?
To be frank, as a manufacturer, I don't even know what we do. We've never done sim. We just go and do the test. So we've never actually done the theoretical computer simulations at all. We just go and test stuff. Love crashing cars into things. It's good fun.
Have you seen, I suppose, is the trend that local authorities and clients are using more of this type of, is it very, very noticeable in terms of I would guess it's an upward trend, honestly, but is it very much exploding, let's say, in a way from a manufacturer point of view, or has it been steadily?
It's been a steady increase over the years. Since I started 10, 11 years ago, it was only really on high-speed roads, the Highways England network, Transport for Scotland, and those kind of guys that were pushing it, and they were the early adopters. But more and more and more, as people have become more accustomed to it, more used to it, and understand the concepts of passive safety more and more local authorities are going down that road as well. I think they have to, now, to be honest with you. I don't think they have much choice.
Yeah. The standard seems to be pushing people up.
Basically, now you have to consider it on any road type now. So you don't have to use it, but you've got to at least consider it and discount it.
Any final questions? No? Very good.
Yeah, go for it.
Just to be very awkward,
Yes.
how are you being affected by Brexit and certification of?
No problem at all. We're a Dutch company,
Okay.
so we're part of Europe. So everything that's tested, we test in over in the Netherlands.
Okay.
So your guys are not going to be affected at all. If you actually did your test in the UK, the European bodies now will not allow you to sell your poles into Europe, but they will. But the British government will accept European poles going in. So you guys are not going to be affected at all.
That's good to know. Very good. So look, just possibly just to offer a word of thanks to you. Look, I think the presentation is very comprehensive. We started off giving a bit of context and showing that Sate has been around for a long time, and going through the different energy absorbing structures and just kind of I suppose defining what types of structures you can get and moving on into the standard, which is very very useful in terms of using the videos and kind of showing the practical and the testing side of it, and even just without going to the standard, but also moving beyond that and saying what products you can use, let's say the workmanship and the specification of the site, and it's all linked together. And I think everyone would be much more knowledgeable on the subject, or especially know where to go with all these different standards and the resources that you've given. So look, just thanks very much on behalf of the Congregation Committee, and just like the round of applause for everyone.